Okay, please introduce yourself. Tell us about your education background and about your teaching history.
My name is Katie Thompson, and I have currently been teaching. This is my 10th year teaching, and all 10 years have been at the Academy for the Art, Science, and Technology in Myrtle Beach. I got a bachelor's degree in biosystems engineering, and I worked for an engineer for a little while, but I had always tutored my way through college, and so after working for about a year, I knew that that wasn't really what I loved to do, and I went back and got my master's in teaching in secondary mathematics from Winthrop University, and that's where I got my initial certification. I have taught every level of math. I've taught Algebra 1 up through Calculus 2 at CP levels and at honors levels. And then this year I'm teaching a new class called aerospace engineering, so a wide variety of math.
And why do you think literacy is important in math?
I think literacy is important in math, mostly for the vocabulary. So often my students, they'll be talking and they'll be like, you know that thing. And when I don't know the thing they're talking about, if they learn the math vocabulary and I make them use it in daily conversation, in communicating their questions or their comments, then it becomes a little more natural for them. When they are presented with any type of problem, whether it be on a standardized test or even on into a career and some type of problem, if they don't understand the math vocabulary, then they don't really understand what's being asked of them or what they need to answer in the question. And so if they're able to read that and understand that literacy, then it enables them to know what question's being asked and how to better answer it. In addition, in communicating their answers, if they're in the engineering world and they need to communicate their findings to somebody else, it needs to be in a way that anybody should be able to understand that question, and not in a made-up vocabulary that they think works for them, but using that standard math vocabulary or engineering vocabulary to communicate their findings so that anybody would be able to understand them. So.
Okay, the approach to math seems to be different than when I was in school. There are a lot more opportunities for students to write with assignments like Think Deeply's in elementary school. Do you think that has enhanced the understanding of the material?
I do. I think historically in math, it was always, what's the answer? Just give me what the answer is. That was the most important objective. But I think where math education has moved to over the last 5 to 10 years is more understanding why are we doing that math that we're asking you to do. Not just, here, can you solve this equation, but where would solving that equation be applicable for a student to use in a career or everyday life, depending on what their career might be. I think this gets tied into what we use across the education system in the Bloom's taxonomy of what level type question we're asking, whereas historically it might have always been on that knowledge and the comprehension level of being able to just recall information or a basic understanding of the information, and that used to be sufficient enough, but we were lagging behind where the rest of the world is in their understanding of math. And so by moving some of our questions, we still need to have the questions that are asked at that knowledge and understanding level, but also deepening our students' understanding of the content and the standards into the application and the synthesis and the evaluation, helps students have a deeper understanding of the knowledge level questions and being able to apply them to different areas, other curriculums, and our word problems, better understanding the word problems.
Do you evaluate the learning style and needs of your students? And if so, how much does that affect your specific teaching methods?
As a teacher, we always evaluate our students based on previous data. We can look up, we have access to all of our students' historical grades, test scores, anything like that. And I think all of that is useful to me as a teacher in looking up, do my students struggle in math? I also look up, based on the literacy that you're talking about, I look up all my students' Lexile levels. That tells me that if I have a student with a low Lexile score, they might have that difficulty in the vocabulary even though they might be a strong math student, they're weaker in their reading skills or their English skills. And so strengthening that literacy component with them just to be able to understand what math am I supposed to do, even though math isn't their weakness. Looking at the historical math grades, is that tied to their low literacy or their low Lexile levels, or is it tied to their weaker math skills, and really knowing the difference in that? A lot of that comes with learning your students as you go. So the data I look at before the kids ever walk into my room, but I'm always formatively trying to figure out where my students stand. And so once they're in my classroom for a few weeks, then I can assess more about their learning needs and really help determine whether their weaknesses come from more of a literacy standpoint and their Lexile levels, or does it come from a weaker math background to be able to move forward with what they need. So I guess to answer your question, then yes, it does alter how I make lesson plans because all of my students are different. So and that's where like our scaffolding comes into play of making sure that we're addressing each of those students' needs and meeting them where they need to be met to be successful in what class they're in.
And that assessment you do several weeks into it, is that just reviewing what work they've done in your class to that point, and then that helps you make that determination?
Yeah, because and that kind of assessment is all just more I don't give them a piece of paper or a test per se on that, but it would be me during class time when we're working on practice problems and walking around and really talking to the students and learning who's having problems with what particular area. And when I'm calling on them in class and their communication with me, are they able to communicate using that math vocabulary of what their findings are and really answering those questions. So it's constantly happening, and hopefully they're improving in that math vocabulary the more I make them use it in class and really understanding what they're trying to do.
Do you require your students to show their work in a specific way, or do you allow them to use whatever methods work best for them?
I think from the get-go, I try to train them on a certain way of how I want them to show their work. It needs to have a logical flow. So often I teach freshmen a lot, and they're coming from a lot of middle school backgrounds, and it's from a variety of different middle schools and different teachers, and so trying to get them to come together to be able to communicate those ideas in a fluid way that you can't just do the math in your head and tell me what the answer is. I need to see supporting work of where did that number come from? How did you arrive to that number? What's the work that the steps that you showed to get to it, but also not having one piece of work here, another piece of work here, another one here, and then my answers back up here, because it's so hard to follow that. It's like writing a paragraph without sentences flowing in an English class. And so if the math doesn't flow, like how did you get from step 1 to step 2, it's the same thing as in an English class when your paragraph structure is all over the place and you have all these sentences put together, but there's no flow to it. And so I try to communicate that with my students of making those connections to showing your work in an English class versus showing your work in a math class. I show my students, or at least I try to, different ways to arrive at the same answer, that there's usually in math, there might only be one right answer, but there's different ways to get to that answer. And so showing them all the different approaches that are mathematically correct to get to the same answer, for me, is a really important thing, because some students understand one way better than the other. And as long as the standard that I'm addressing doesn't involve having to show your work in this one particular way, when we get to an overall assessment, as long as they want to show their work, as long as they're showing their work and it is correct math, then I'm okay with them using any math way of getting there, unless the directions specifically say they need to do it in a certain way, because that's the standard that I'm trying to see if they've mastered. As far as them doing it in which way works best for them, sometimes what they think works best for them isn't really a universal math way of communicating, because it works in their brain and it clicks in their brain. But when I ask them to communicate to me how it's working, they can't really use that good math vocabulary and that math language. And so I stress to them, that's fine, you can do it in your way, but you got to be able to communicate it to me or to any other person for them to understand. So really stressing to them that it needs to be more of a universal communication versus, well, it works in my mind kind of thing.
Do you focus on any other standards outside the ones specifically used for math when creating your lesson plans?
Most of my lesson plans are centered around the state standards for math, obviously, but we do involve some technology standards. We try to incorporate with our students 21st century skills of timeliness, of punctuality, of organization, and just being a well-rounded person for a workforce. So we try to incorporate those types of standards and skills into all of our lessons at our school, but not necessarily pulling in other standards into my math lessons. In my class, though, often especially in my calculus class, and even in some of my lower level math classes, there are lots of connections to physics and other areas of science. And so even though it might not be in my standards when developing my lesson plans, I try to make those connections for students so they can see that this is something we're doing in calculus, but they might also be doing in their physics class in the next unit, or they may have already previously done it. So I think it's important for students to see those connections between different curriculums and different classes, but it might not necessarily be what's driving my lesson planning.
Has technology changed the way you approach your lessons since you first began teaching?
I think I started teaching, like I said, this is my 10th year teaching, and so the technology drive, or the technology, I can't think of the word right now, but the using technology started really when I first started teaching. And so one of the challenges we always had when I was going through my ADEPT and when I was getting recertified was the technology component in your lessons, and how are you incorporating different types of technology into your lesson. So I think that that's been there throughout most of my teaching career, just being a younger teacher. So I know that for some of my colleagues that have been teaching more like 20-25 years, that it's been a big shift in their lessons and making them more interactive with technology. We have students that technology is at their fingertips, and that's how they learn best. Sometimes kind of a difference of opinion, but you want to use how your students learn and what's available to them, but also helping them understand that paper and pencil isn't always the best way to go. One of the biggest types of technology in math is a calculator. And so my students are always like, well, if the calculator can do it for me, then why do I need to do it? But the technology, the calculator, I tell my students, they're only as smart as the user. And so if you don't know what you're typing into your calculator, then how do you know that the answer that the calculator's spitting out is the right answer or a reasonable answer? So I think the important thing for us to communicate with our students in using technology is, does my answer make sense? That when they type that equation, that graph, whatever they're typing into the calculator to use, when I'm getting an answer out, does it make sense in the context of the problem? Is it a reasonable answer? For instance, a couple of years ago on an AP exam, one of the questions, it was about a potato that had been taken out of the oven and placed on top of the stove to cool. And it was a big word problem, so definitely literacy involved, but it had an equation that they had to apply to the cooling of the potato. And when you have students, so it started out at 96 degrees Celsius, or 91 degrees Celsius sitting on top of the stove, and it's cooling. And so when you get an answer that is negative 32 degrees Celsius, that your potato all of a sudden froze, does that answer, it was a calculator active question, but does that answer make sense in the context of the problem? Or there were answers where students gave answers like 200 degrees Celsius, where apparently the potato spontaneously combusted and caught on fire on top of the stove while it was cooling. And so I think that that's really important, that when we do use technology that we're teaching our students, does it make sense in the context of the problem? Is it a reasonable answer? And incorporating that technology in appropriate ways.
How do you use literacy in your everyday instruction? I know you've touched on that quite a bit already, but also in your professional development.
I think in professional development, like you said, I've talked about it in teaching, but in my professional development, I think it's important for me to be up to date on the newest education initiatives that are going on, reading technology articles, reading math articles, that what's working for people in certain classes, or when you have debatable ways of teaching certain curriculum, am I staying up to date on those best ways for my students? So I think that's more where the literacy would come into play for me with my professional development, is that am I constantly learning? Am I constantly trying to figure out the best way or the best approach for my students, and to incorporate some of these literacy standards, some of the technology standards, and meeting my students where their needs are.
Are there specific resources or journals that are sort of your go-to when it comes to learning those new things, or how do you discover those new education initiatives? Where does that information come to you from?
I mean, that's the beauty of technology. Some of it is Facebook. I'm in a lot of different Facebook groups that are not necessarily professional organizations, but they are professional teachers. One for AP Calculus teachers, and so people post different resources on there, and I'm always clicking, and once I click once, it leads me to some other article or way of teaching something. The AP Calculus and the College Board, they have a website, and being up to date on what the standards are and what the changes to my curriculum might be. I'm in the National Council of Teachers of Mathematics, which is the national organization for math teachers. And so I get emails every now and then of journal articles with that. So I just think being in professional organizations, and even though Facebook isn't necessarily seen as professional, it is a way to easily interact and build a community with people all over the nation that are teaching calculus, whereas not very many teachers in this area are teaching calculus. So it allows easy ways of communication and sharing of information.
What do you consider success in your classroom for your students and also for yourself?
I think for my students, it really depends on each individual student. They all step into my classroom with different backgrounds, with different goals. Like I've talked about teaching AP Calculus a couple of times, and the ultimate goal for most of my students is to get that college credit by passing the AP exam at the end of the year, and they can get that by making a 3, a 4, or a 5. Some of my students, I hold them to the standard they should be making a 5 on that exam, but there's other ones that I celebrate a 3 just as hard as I celebrate a 5, because that's where I want to meet those students, and I want to celebrate that with them, because they might not have had the chance of making the 5, but getting that 3 was just as big of an accomplishment to get that college credit for them. So I think that success for my students in the summative assessment way is varying depending on my student. The success for me is, did they walk out of my class learning something more than what they knew when they came into my classroom? Have they mastered what I want them to master? But also, sometimes it's about being a good person too, not always about the math skills that they're learning. But I think as long as they've learned something more than when they first step foot into my classroom, I feel like I have those students have made some type of success in my class. For me, I'm a perfectionist, so like when it comes to the AP exam, I want every single one of my students to pass, because I don't want to let any of my students down when they have that chance to potentially pass the exam. But I also think that success for me is I teach a lot of upperclassmen, and so when they're in college and I hear back from them about what they learned in my class and how it was helpful for them later on, that it meant something to them in the future versus just while they were in my class. And so did I help them with something later on did it make an impact for a future class or a future connection that they were able to make, is sometimes where I get my internal success from, I guess.
You've been involved in grading AP exams at the national level, and you spent some time at Auburn this summer for training. So how important is that experience, outside of the classroom for you?
The AP grading is definitely a way of professional development. That's where I actually learned about that Facebook group and am able to interact with other AP calculus teachers. I think going and spending 10 days immersed in this calculus of grading AP exams is one of the best professional developments I could do. It taught me, as far as the literacy component is, how have students really communicated their ideas, because the test is on a piece of paper and that's all they have to communicate their ideas. They can't go back like a lot of our students do. If I hand back a test or a quiz to the student, they'll be like, well, that's really what I meant. And they don't have that opportunity to do that with the AP exam. And so teaching students that you have this piece of paper, you have this hour and a half to communicate to people that you know what you're doing in math. Don't skip that step. Don't skip the words. Don't use abbreviations. Make sure that you're communicating so that if the calculus teacher from California is reading your paper, they know what you meant. And so really seeing that when I'm at that professional development, most people have the mindset, we're not grading the students to hope that they fail. Like, it's more to hope that they did master those skills, but making sure that they did it in a way that's communicating good mathematics and good vocabulary with the mathematics. So that was kind of the AP grading, plus you're around a bunch of math nerds, which is always fun for me. With my training in Auburn that you brought up this summer, that was actually for my new class, aerospace engineering, that I mentioned earlier that I'm teaching. And one of the biggest things with the aerospace engineering curriculum is the addressing math standards within the aerospace engineering, addressing science standards within the aerospace engineering, and addressing the literacy component within aerospace. It changes completely how I've been teaching for 10 years and teaching this class. Everything that I learned this summer was about the engineering design process, that students need to ask and inquire. They need to imagine. They need to plan. They need to then create and then experiment, improve, and then communicate. And I think that going through that 7-step engineering design process relates a lot of literacy components, but also cross-curricular standards, like you mentioned earlier. Did I take into account other standards when I'm planning my math? I might not specifically, but with this aerospace class, it's just kind of embedded into the curriculum that I'm planning. So in all of those stages, in the ask and inquire stage, the kids have to do research that's applicable to what project they're working on at that time. And so it really helps them to, they have to research and they have to find valid articles that are related to the problem statement that they were given about the particular project they're doing at that time. And so in the course 1 that I'm teaching right now, they have 6 different projects, but with each project they have that research component. They have to keep up with an engineering notebook that's a very technical notebook, but they have to write reflections about what they learn each day. And then finally at the end, when they're communicating, they have to use the industry language. They have to be able to communicate it to me at the beginning, but I'll be inviting in professionals from the community to come in on those presentation days to really see, are they communicating in that industry language? Have they learned what the industry standard is for going into a field of aerospace? Granted, they're freshmen in high school, but they're still learning that now to be able to have a leg up when they get further on. So my training in Auburn this summer, as far as that literacy component and tying things together across the curriculum, is just embedded in, and it's really cool for the students to see. I was doing this math in my math class, and this is how it's applicable to this project I'm doing that is aerospace engineering. Or the English teachers bringing them in and them getting to see the research component, and them having to do APA South citations and what they're learning in their English class is applicable to this project they're doing in their aerospace class. So I think that's very cool for the students, and as well for other teachers in my school to see that being applied in this new class.
In sort of our everyday conversations, getting to know each other over these last couple of years, you had mentioned one of the things that you're most excited about every year with school is the senior projects, for lack of a better term from my side, that you either that you get invited to see or that you're required to see at the end of every year. Can you talk a little bit about those and how the literacy standards and go into that a little bit?
So at my school, it's a program school, and each of the students have a major that their electives are concentrated in that particular area for their junior and senior year. And so since they've spent so much time in that class for a 2-year period of time, they pick a different, a senior mastery is what they do at the end of their senior year to show the culmination of what they've learned over the past 2 years. And so within that senior mastery, they have to pick a research topic and then tie in that research to their senior mastery. And so we have students from pre-med and pre-engineering and art that they research different components that are related to whatever their main project is. And so they have to apply those literacy standards in how they research, how they cite, finding good sources, but then also communicating it. These senior mastery projects, it's a 45-minute presentation that they have to give to a panel of teachers, of community members, of their senior or their major teacher that's in that particular area. And they have to communicate how they've learned different 21st century skills, different life skills, but also different STEM standards. And in those STEM standards, even though it's science, technology, engineering, and math, there is a literacy component within each of those areas that they have to talk about how they incorporated math into their project, how they incorporated technology or science into their individual projects. And so I think the literacy skills that they're able to apply to those projects in the research and the communication is shown, which is a big thing for high school students to be able to show. So,
is there any one project that stands out, whether it was your specific student or another student that you were invited to be part of that panel?
I mean, I guess it's standing out to me because it was recent this year. I had a student and she was a woodworker, but so she was in the art major, but in her senior mastery, she took me for AP Calculus AB and BC. So strong math student, phenomenal artist, and just being able to talk about each of her individual projects all had a science aspect to it, because it was always talking about endangering our sea animals, our turtles with the plastic around their necks, or the birds that get caught in netting. And so she had done research about the pollution and how people are leaving our footprint in bad ways for our environment and the sustainability of our sea life. But also in making each of the designs, she had to talk about the math that was involved because of the proportions that she had to use, but also the technology that she used in laser cutting, and sometimes in the types of materials that she was using, and the science behind mixing the materials together so they would form the right colors or the right consistency to be able to mold it or cut it how she wanted it to cut. So I just think she just did a phenomenal job of being an artist, being appealing to the eye, but also incorporating all of those standards. And then at the end, her communication of everything was just phenomenal. And her language that she was using the technical language and the literacy that was behind all of that. So,
okay, thank you very much.
Thank you.